Hi everyone, welcome to my lecture. This lesson will be about routing with redundancy, redundancy, redundancy. Right. Uh, we'll speak about IP packets, and we'll also speak about another topic, which is, if I remember good, it will be about subtopic. It will be about Internet routing protocol. Well, let's start with me. What we'll learn in this lecture. Um, IP packets. On the massive network known as the Internet, competing devices send all kinds of messages to other competing devices. A message might be a teeny ping to check if another device is online, or a message could be on entire web page. But there is a limit to how large a message can be, since there is a limit to how much data can be reasonably reasonably transmitted at once by the physical network connections between devices. That's why many networking protocols split that's each message into multiple small packets. The Internet Protocol IP describes the structure of the package that reads around the Internet. Each IP package contains both a header, 20 or 24 bytes long, which is we have some shame like just think the left side is just tagging 24 bytes, and the upside is tagging some 6 bytes, 4 bytes, something like that, like 32 bits. This side, it will be 24 time 8 bit, like you can think. It will be more places. It will take more data, I mean, but for the upside, which is, you can think about web page, the upside will take only 4 bytes information, 32 bits. The left side from age, it will go below, and all data places will be 20 or 24 bytes long. And data variable length. The header includes the IP addresses of the source of the destination, plus other fields that help to route the package. The data is the actual content. It is really like ladder, okay? Anyway, we'll speak about it. IP, the IP number, IP number, like what, your address. Okay, IP number is like your address. IP address is like your home address. Okay, the anyway, we'll speak about it. Let's go again there. um to route the package, the data is the actual content, such as string of letters of part of the web page. I told you. Let's check it. Oh, what I did, I need to go back to there. Here. So we have here version, length, service type, and package length. It's just 4 bytes. This displays like 4 bytes, and the header plays from here. Just two plays 24 bytes. So just displays, okay, is just 4 bytes, and display is 24 bytes, which is all this information plays will be 4 bytes. Okay, yeah. I think we got it right. The data example of data plates we have here, the 24 bytes. Maybe you've seen my screen. It's just think like this point, okay? This point is just 4 bytes. You can think like that, and this place is different, and this place will be 4 bytes, and this place will be 24 bytes for header place. What happening? I don't know, but I hope everything is good. Now you can think of IP packets like postal letters. The header is the envelope with all the routing information that's needed by the post office, and the payload is a letter that's read only by the recipient. I told you the same methodology for internet and for the postal these ladders is the same. Source IP addresses, there's right, destination IP address we will write. So our sender IP address and receive receiver IP address, and the data is inside that, right? Just like the postal systems routes postal ladders around the world, the internet protocol routes IP packets around the internet. It's the same. Let's come down. Yeah, the another one is the internet routing protocol, which is I told you. Now let's look shims. Let's understand what is turning there with it. Okay, what we are talking about. In the Internet Protocol (IP), so Internet Protocol, computers split messages into packages, and those packets hop from router to router on the way to their destination. Well, what I'm saying, the message is just exiting from computer, and it's going with the wires. So it's with some wires, a fiber cable. It came in other things. Okay, all right. Just digital bits is just floating there, but they are just information, okay, like spikes in neural brain system. Anyway, these ones are router, okay, router. They are helping to give information, to send information fast. Well, we have router here. This router just looking for mindly address, which one is will be short way to reach this point. uh, is going like that to there. Well, we will talk about it, why it's going like that, why it's not going from there to there. It's not mindly from here, but let's you learn everything, because router will help us for about IP hierarchy, which is, I told you, like Comcast network company, and sub-hierarchy. We have computers, we have lab, and we have in lab computers. There we have the hierarchy, like in four part. We told for two place for two for two octal place. We told this is lab, and the for two end of this two and two octal place, it is for lab. And now we'll learn all of them. Anyway, let's step through the process of routing a package from a source to a destination. Sorry, I have little sleep because I am crazy. Like I just made four video like German, Japanese, French, and now I'm doing this computer science videos. Also, I'm working data science at the same time today. I work math, physics, geometry. Anyway, okay. Step 1. Send package to router. Computers send their first package to the nearest router. A router is a type of computing device used in a computer networks that helps to move packets along, right? Yeah, it's just what, this is our IP. It's going this location from this location to there. But first we need to go this router. Where is that? Yeah. You likely have a router in your home, a classroom right now, and that's the first stop for your current computer packages. Okay. Step 2. Router receives package. Okay, routers receive package. Now what it will do? When the router receives a package, it looks at its IP header. Okay, it will check there. The most important field is the destination IP address, which tells the router where the package wants to end up. Okay, this place is important here. What? Well, let's go a little up. It's little in crazy point anyway. Yeah, IP header. So it's like what, I told you this two hierarchy point, which is two place, can be company or can be some place, and this one can be computer number, like computer IP. Yeah, we can think like that, okay? Source IP address, which is our sender station, destination IP address, which is receiver, version, time to leave, and more fields here. I told you this is in which is I told you the first. I showed you that like 24 bytes. I told you the information there is staying there. Anyway, this is destination. This is important for us. Step 3 router forwards package. Okay, let's check it what it's doing there. The routers has multiple path. It could send a package along, and its goal is to send package to a router that's closer to its destination's final destination. Okay, so it needs to change slack to one. Which one is better? What do you think? 1, 2, 3. Let's check it. No, we'll check it. How does it decide? This is important. Yeah, it's going, but like what? It's going in the cables, in the fiber optic, or in the Wi-Fi, like radio signal. Just check it. How does it decide? The router has a forwarding table that helps it to pick the next path based on the destination IP addresses. The table does not have a row for every possible IP address, right? Because there are 32 power of 2 possible IP addresses, which is it's looking only for the closer one. So it's just checking which one is close and it's just trying to go there faster, okay? IP addresses, and that's far too much to store. Yeah, it's really difficult. So for the table. Instead, the table has rows for IP address prefixes. I mean, well, what we are saying here, IP address prefix, which is this point, is like 91, 112, 91, 198, 192.92. It's stream. Let's come down. So already we have many more there. IP addresses are hierarchical. When two IP addresses start with the same prefix, that often means they are on the same large network, like the Comcast SP network. So it's important, I told you. So the means they are on the same large network, then the router can go fast. So the router can send the letter or message very fast if it's see the same prefix. Okay. Router forwarding tables take advantage of that fact so that they can store for less information. It's like hierarchical schemes. Once the router locates the most specific row in the table for the destination IP address, it sends the package along that path. Okay. Like what? It will check it. It will see there this, and it will say, "Oh, this is my way. I need to go from there because source, so sender places that, receiver is just starting with this number, and I need to go from this way, not from this way because it's starting with another things like with another numbers. But let's later check it. So the final router forwards message. Like what? Like, let's check it. Step 4. Final router forwards message. If all goes well, the package should eventually arrive at the router that knows exactly where to send it. What I'm saying here, IP address prefix path. So here, then 91, 198, 174, 192 is direct. It's going from here, not going from 91 or 192, because our our IP addresses. So we know, right? We indicated it right before. So if you know about IP address, then we can understand it. It's need to go from here directly, not from others, right? So I'm speaking like ghost. The router can now send a message to the destination IP address, which may be a personal computer or server. Okay, so it can be anything there, but it's how to go. This mean like that, right? Our source and receiver computer IP addresses. Well, so it's all friends. I think you understood, right? I hope you understood. It's making me crazy. Just bring it like that. Another lecture will be about redundancy and fault tolerance, and we'll do some practice. We'll solve some practice questions, and then so we'll go another topic. Well, so it's all for today. I hope you enjoyed with me. I hope you learned more about IP packets and the routing strategy, how it's routing, how it's working, how is this information going in cable, in Wi-Fi, radio signal, and all this people, all these guys working there. So internet protocol also I think you understood this point, and all just here. Okay, this is that last point. Let's bring it in good situation, position. Okay, like that. Thank you so much for joining. Have a good time there.